Today we'll discuss about your next searching algorithm in your graph, that is called DFS or depth first search. Depth first search. So the next concept is called depth first search in your graph. So let me tell you in brief about the algorithm behind your depth first search. So what the depth first search algorithm does, we need to pass one graph as the input. We need to pass the one graph as the input. So the first step is that in the step 1, what we'll do, we'll go for your initialization. In the initialization, we are going to apply 3 operations. The first operation is for every vertex in your graph G, paint every vertex. Let's say I'm writing the V. Every vertex color is assigned as your white color. Once you have assigned white color to every vertex, then assign the predecessor. I'm writing predecessor to every vertex B is initially nil, and rather you are going to use the 2 timestamp in your depth first search. So the time value will be assigned at the time of the searching, and what the time is initialized, so the time value is also initialized with the value 0. So in your DFS, 2 types of time value will be applied over every vertex. So one time is called the starting time, when you are going to visit the vertex. When the process will over, then we are going to assign your final timestamp or final time value. That I will discuss later on. Then after doing the initialization, then we will go for your starting of your DFS. Then step 2 I am writing here. What the step 2 says, that for every vertex, let me write that as U in graph G. If the color of the vertex, U equals to your white. So if you think about, initially every vertex is white, so the first time when you are going to visit the vertex, so definitely the condition will be true. If your condition is true, immediately you go for the Dfs traversal. Over the vertex with the white color. Now, this is the DFS approach. In the DFS algorithm, now we'll go for the next step of your DFS algorithm, that is called your Dfs Traversal. So this is the process called by your DFS algorithm, that is Dfs Traversal. What the Dfs Traversal does? It takes the same graph G with the vertex U. Now, Dfs Traversal, what we will do? The first step I told you that it uses the timestamp. So increase the time value. Initial time value was 0. Now the time value plus 1. So now I can say that the value is now 1. So at 1 unit time we will process your vertex U. So second step of your Dfs traversal is assign your starting time, I am writing S, the starting time of your vertex U as the current time, and change the color of your vertex U to the gray, so that we'll process the vertex U. Previously vertex U was white, now the color is changed to gray. The gray means processing is started. We can say that way. Then in step number 4, we will find the adjacent vertex of your U. So for each adjacent vertex of U present in the graph G. So here we will find the adjacent vertex. Suppose adjacent of U is your V. I am writing here V. For each adjacent of U, that is V, present in graph G, if the color of V equals to white, if the color of B equals to your white, then write the predecessor of V will be U. Why? Because B is the adjacent of U. If the V is a white color, then we will write the predecessor of V is your U. Then we will call the same Dfs traversal algorithm here. Then Dfs traversal of your current adjacent vertex B over the graph G. So here you just imagine that if you are getting the white adjacent vertex, then you will assign the predecessor as U and call the same process over the current adjacent vertex B. If you are not getting any white color adjacent vertex, then you are going to change the color of your U to black. So when you will paint the black color, if you are not going to get any adjacent vertex of U with white color, then only your U will be painted with the black color. Black color means process is over. Then here you will assign one. Then final timestamp is your recent value present on time. We can do in that way also. So this is the whole algorithm behind your Dfs traversal. So let me take one example. You will get the clear knowledge about Dfs visit or Dfs traversal algorithm. So let me take one example of your Dfs. Example of Dfs algorithm. Depth passage. So suppose I am having a graph which appears in this format. So there is a vertex called, let's say, A, which is connected to the vertex B. Vertex B is connected to, let's say, that vertex C, the directed graph, vertex C, and vertex C, let's say it is connected to vertex D, and vertex A is also connected to vertex D, and vertex D is also connected to vertex B. Just think about this is the graph given to you, and it is asked go for the Dfs traversal. So as per the algorithm, the first step is initialization. In the initial step, what we are going to paint all the vertices with which color? With the color white. So if I recall that here, just think about initialization process. Every vertex will be painted with the white color. predecessor nil, and the time value initially is 0. Now what should we do? In your given graph, I am going to paint with white color. I am going to paint with the white color. So here I am writing W means your vertex A is painted with white color. Here I am writing W near to B means the vertex B is painted with your white color. Similarly, vertex C is painted with white color, vertex D is painted with white color. And the parent is nil. I am not representing any representation here. Whenever I will get the parent or the predecessor information, I will make the double line. I will tell you in the due course of time. So the first step, initialization, is over, and the time value here I am writing time equals to 0. Now you can start the DFS from any vertex. So let's say I am going to start the vertex A. If I am going to start from the source vertex A, so what will the starting time? So as per the DFS widget, we are going to start the DFS for every vertex U present in the graph G, provided the color is white. Yes, color of A is white, then you will go for Dfs Traversal A. In the Dfs Traversal A, so the Dfs Traversal function or the procedure will be called. If you are going to call the Dfs Traversal function, how the Dfs Traversal function looks like? So I told you that here the Dfs Traversal, we have to increase the time value. We will assign the starting time of your A as a time plus 1, 0 plus 1, 1. So let me explain to you. So what should we do? Now your time equals to how much? Time plus 1, 0 plus 1, the time value becomes 1. So the time value is now 1, so I can write that here. Initial time, let me write in another line, time equal to previous time plus 1. So here we got the value was how much? Your time value is 1. 0 plus 1, it becomes 1. So here I have written that the value here as 1. Then the next step, what you will do? Assigning the starting time, then change the color to gray. So white color is now changed to your gray color. The vertex is now painted the gray color. Then find the adjacent of A. So I can find the adjacent of A as B or A as your D. So I will take only one adjacent vertex at a time. So just think about A, let's say B is the adjacent vertex. Then what will happen? You check the color of B. Is it white? Yes. Then change the color to your gray color. If it is white, then what is the algorithm telling? What the algorithm says? The algorithm says that for every adjacent vertex, if the color is white, write the predecessor of V, predecessor of adjacent vertex as your U. Then start the Dfs Traversal. We will call again. So what will happen here? I can tell you that in this case, your B is the adjacent vertex. The color is white. Yes, color is white. Then predecessor will be your A. So I am writing double line to represent U as the A as the predecessor of your B. Then once you write the predecessor, then call the Dfs again. Dfs again means find the your time value, increase the time value. What the time value? Time equals to time plus 1. So next time your time value will be 1 plus 1 becomes 2. So assign the starting time. I am assigning the starting time here too. After assigning the starting time, then change the color to gray. So color is now changed to gray. Then find the another adjacent vertex B. What the adjacent vertex B? C. Is it white? Yes. If it is white, then what should you do? As per the algorithm, write the predecessor as your B. If it is white, then we can write that B as the predecessor. Once you have written the predecessor B, then call the Dfs Traversal over C. For the Dfs Traversal says that change the time. So time will be how much? 2 plus 1. so becomes 3. So assign 3 as the starting time of your C. When the starting time is done, then change the color to gray. Then find the adjacent of your C. Which adjacent? C, D. Is it white? Yes. If it is white means write the predecessor. After writing the predecessor, Dfs traversal over the D. Dfs traversal D means assign the timestamp. What is the timestamp? Previous time value plus 1. So previous time value is 3. So I can write that 3 plus 1 becomes your 4. So here starting time is 4. I have written that. Once I have written the starting time, then change the color to gray. After the painting with the gray, find the adjacent vertex. Which is the adjacent vertex? B. But is the adjacent vertex B is having the color white? No, it is a gray color. Whenever you are getting the gray color adjacent vertex, immediately you have to paint your U is here, D to your black. And whenever you assign the black color, you have to assign the final stamp. Why the final stamp? Because the vertex is processed completely. We are not getting any new adjacent vertex. So that's why you have to assign the final stamp. What is the final stamp? That is previous time value plus 1, 4 plus 1. It becomes your 5. So you write that 5/5, 4/5 right. 4 is starting time, 5 is the ending time or the final time. So once you assign the final stamp, you have to reverse. If you are going to reverse, the way we have traveled, the same way we have to return. So we reach to your D from your C. So back to your C. We'll search for any white color adjacent vertex. There is no white color adjacent vertex exists in your C. So that's why we have to change the color to your black. And assign the final timestamp. So what the final timestamp? The previous value plus 1, 5 plus 1 becomes your 6. So here we write that 1/6. And once you assign the final timestamp, you will return to your B. Is there any new adjacent vertex white color? No adjacent vertex. So you have to assign the final timestamp. What is the final time value? Previous time value 6. 6 plus 1 becomes 7. So you write that here 7. And change the color to your black. This is the vertex B, here the color B, black. Then once you painted to the black color, you have to return to the predecessor. With the predecessor of your B, that is A. Find any adjacent vertex with white color. A is having another vertex D, but the color is not white, it is a black. So that's why you have to assign the final timestamp. What is the final timestamp? That is previous time 7 plus 1. 7 plus 1, that is 8. So you will assign final timestamp 8 as here and change the color to the black. Now there is no more vertex exists. The algorithm will be completed. The algorithm will be terminated here. So then what is the result? The result we can write here. Look at the timestamp. First timestamp is A, then second 2 is given to B, then next timestamp is 3 assigned to your C, and next timestamp is your D. Okay. So we have covered all the vertices using the Dfs traversal with the result as A, then next vertex B, then next C, then next vertex your D. Example number 2 for your Dfs algorithm. So what is the input to your Dfs algorithm? That is your graph. Let me draw a graph. Suppose we have a directed graph. Okay. Fine. So let's say this vertex A, this vertex B, let's say the vertex C, let's say the vertex D and vertex E. So 5 number vertices are there. So as per the Dfs algorithm, what should we do? We have to paint every vertex with white color. So here I am writing W for white, and the color B is white, color C is white, color D is white, and color P is also white. So every vertex is painted with your white color. Then next, what should we do? The next is assign the time value. So here I am writing initial time value, that is a 0. Let's say we are going to start from the source vertex A. If you are going to start from source vertex A, so assign the starting timestamp. Starting timestamp is your previous time plus 1. So previous time is 0, 0 plus 1, it becomes 1. So here I am writing the starting time is 1. And once you assign the starting time, then what should you do? Then change the color to gray. Here I am writing Z. So white color vertex A is changed to your gray color. The one change to gray color, find the adjacent vertex. So we have another adjacent vertex of A, that is B, and there is also second adjacent vertex C. You are going to take only one adjacent vertex at a time. So let's say I am going to take B. So is the color of B is white? Yes, it is white. White means mention the predecessor of B is your A. Once you mention the predecessor, then apply the Dfs traversal over your B. So if you are going to apply the Dfs traversal to B, so what will happen? Assign the time value. Time value will how much? Your previous time plus 1. Previous time is 1. 1 plus 1 becomes 2. So this is your time value I am writing here for your B. Once you have assigned your time value, then change the color to the gray. Once you change the gray color, find the adjacent of B. So do you find any adjacent vertex? No. So B is the adjacent of C, but B is not having any adjacent vertex. So if you are not getting any adjacent vertex, immediately change the color to black and assign the timestamp. So what is the timestamp? Final timestamp. Whenever you assign the black color, we will assign the final timestamp. But the final timestamp, previous time plus 1. 2 plus 1 becomes 3. So here writing there the final stamp as 3. So B is processed completely. Then we have to return to your predecessor node. Which is the predecessor B? That is A. After returning to the predecessor node, here we will find the one adjacent vertex with the white color. So there is a two adjacent vertex, one is C, another is E. You can take any one of them. So suppose I am going to take C as the adjacent vertex. So is it white? Yes, it is white. White means assign the predecessor of C as your A. So I am making double line to indicate that the predecessor relationship. Once you assign the predecessor relationship, then apply the Dfs visit over or traversal over your C. Dfs traversal what? Find the adjacent of C. Which is the adjacent of C? Before moving to adjacent, you need to find your timestamp. What is the timestamp? Your previous time plus 1. What the previous time? Previous time was 3. So 3 plus 1 becomes your 4. So here it is 4, and change the color to gray. After changing the color to gray, find the adjacent vertex of C. With the adjacent vertex C, D. Is it white? Yes. If it is white means mention the predecessor relationship. After finding the predecessor, then you have to change the color to your gray. Assign the initial timestamp. Initial timestamp is what? Your previous time plus 1. For a plus 1, I am writing here 5. So here, let me write here 5. So once you have assigned the timestamp, then we'll go for the finding the adjacent of D. Which is adjacent of D? E. Is it white? Yes. If it is white means mention the predecessor of E as your D. Then find the time value of E. What is the time value of E? Previous time plus 1. 5 plus 1 becomes 6. So I'm writing here 6, let's say. After assigning the time, change the color to gray. After changing the color to gray, find the any new adjacent vertex with white color. There is no new adjacent vertex connected to E with white color. So that's why it will be assigned as your black. It will be painted with the black. Whenever you're painting with the black, what should you do? You write the final timestamp. What the final timestamp? Previous time value plus 1. What the previous time value? 6. So 6 plus 1 becomes 7. So here we'll write that 7. Once you assign the final timestamp, we have to return using we have to return to the predecessor. What is the predecessor? D. Predecessor is D. Is there any adjacent vertex with white color? No. So that's why we have to paint with the black color to your D and assign the final timestamp. What the final timestamp? Previous value plus 1. 7 plus 1 becomes 8. So write here 8. Then you have to return to the predecessor of D. Predecessor D is C. Is there any new adjacent vertex with white color? No. There is no adjacent vertex of C with white color. So immediately you change the color to black. So C is convert to black color and assign the final timestamp. What is the final timestamp? Previous time value is 4 and the final time value is what? Your previous time value is 8. 8 plus 1, that is your 9. So starting time is 4 and finishing time of C is 9. From C, we have to return to the previous node. What is the predecessor node of C? Is your A. So the double line is helpful to return to the parent or the predecessor node. So we reach to A. So from A, we will search for the any new adjacent vertex. Is there any new adjacent vertex with your white color connected to A? No, there is no new adjacent vertex with white color for your vertex A. So that's why it will be changed to your black and assign the final timestamp. What is the final timestamp value? Previous time 9 plus 1 becomes 10. So write the 10. So we have covered all the vertices using the DFS approach. So the result of your Dfs traversal we can find from the timestamp. So what is the time value for your starting node? 1. So A. We started from A, then we move to your B, its starting time is 2, then we move to your B to there is a final timestamp 3, that is the B also, then return to A, from 3 to which one is having the next timestamp? C. C is 4, which is the next timestamp vertex containing 5, so D is a vertex with the timestamp 5, so you write that D. From 5, the next timestamp is 6. So which vertex contains the timestamp value 6? E. So you write that E. Oh, so here we just look at, we have covered all the vertices using your Dfs traversal. So first we move to A, then B, then C, then D, then E. So this is your output of your Dfs traversal algorithm.